A C++ program is divided into two files. One is going to be the header file, and the other one is going to be the implementation, the CPP file. We're going to see here an example of a C++ program. I like always to, when we are learning a new language, to give an example of the program so you can know the details and you can get a holistic view of the whole of a program in that language. So you will see, we're going to define here stack data structure. The stack is a data structure that has two methods, push and pop. Push pushes to the top of the stack, and pop removes an element from the top of the stack. So it's going to be a LIFO data structure, last in first out. So this data structure, this stack is going to be a stack of integers. And you will see that the C++ class is going to be divided into two files. One is going to be the header file that is going to end with .h or .hh. Usually it's going to be .h. Usually you write the name of the class with dot and h. That is not required like in Java. In Java has to be the name of the class, the name of the file. However, in C is more flexible. Needs to be maybe another name. However, it's strongly recommended that the name of the class is the same as the name of the file. Then there is going to be an implementation file that is going to be a .cc or .cpp file. .cpp is going to be the most common extension for C++. So we are going to have an stack.cpp. The stack.h is going to have the header file, just the prototypes, the definitions of the methods and the class, and the .cpp is going to have the implementation. And then the programs that use the C++ class are going to include an stack.h. They are going to have bound include stack.h to include all the definitions. So let's start with stack.h. So stack.h is going to have first these macro instructions, pound diff and def stack.h and pound defy stack.h. That is not required, however, is strongly recommended. This is going to be used in the case that this header file is included twice or more. What it does, this macro instruction, is if the stack_h macro definition is not defined, then it's going to go ahead and include the whole header file, and it's going to define a macro stack.h to prevent that this file is going to include it again. So the second time, for example, that this stack.h is included for some reason, maybe the main file or another file, or maybe a second file, a second header file that uses stack.h, then the second time we'll find that the stack.h is already defined, so it's going to skip the whole header file, right? It's going to go up to the header file. So these two lines is to prevent this header file to be included twice. Then we're going to have class stack. This is how you define a class in C, very similar to what you have in Java. Then there is going to be private colon, that it is going to mean that all the variables, member variables or methods that are after private, they are going to be private, can be accessed only by the class methods. Then, for example, in this case we have max stack. That is the maximum size of the stack, the top, and the array that where we store the stack. Actually, it's going to be stack of doubles. And then all this is going to be private, so cannot be accessed from outside the class. Then we're going to have public, so it's going to be all the methods that are going to be public, like for example the constructor, the stack, where we pass the maximum size of the stack. Then we have a definition that is going to be for push, where we push the value and then returns a boolean that is going to be true if we successfully push into the stack, or false if the stack is actually full. Then we have pop, that is going to be another method that is going to extract one element from the top of the stack. It's going to return true if we successfully get one element from the stack, or false if the stack is empty. And then here we pass the value. However, it's going to be passed by reference. What it means is that what we pass in here has to be a variable, right? It has to be a variable. and the value that we pop from the stack is going to be stored into that variable that we pass in here. This is this definition is from C++. This is a reference variable. That what it means is that if this argument is modified inside the method, then that variable, the variable that is passed as argument, is going to be modified as well. What it means in here is that we don't need to use pointers like we used to pass by reference in C, but actually what it means is that if we pass a variable here and the variable is modified, the argument is modified, the variable will be modified. And that is going to be modified with the value that we extract. Then we have also getTop, that what it does is return the number of values, the number of values in the stack, how many elements are there in the stack. And here there is a keyword that is const, and this const, what it does is we promise that this method will not modify the class. Now, this keyword is not necessary in the sense that the class still will work without the const. However, what we are doing in this way here is that we tell the compiler that this method will not modify the class, the object, right? And the compiler will make sure of that. If we try to modify the member variables of the object in this class, then the compiler will give you an error, right? So the reason you do this description is that you want the compiler to provide to give you errors, possible errors, as soon as possible, so they are not going to cause problems later on in the execution when the program is actually executed. You want to know about the errors at compilation time instead of at execution time. That is one important thing of compiled languages like C++. And this const, basically you say that this method is going to be read-only, that is not going to modify the class. And that is good also because that is going to prevent bugs that can be fixed in 2 minutes. They don't go at the execution when it is too late, maybe when you deploy the project, your program, that reaches thousands of users, and then you know that there is a problem, right? And then it's going to be much more expensive to fix the problem. So you want these problems to be done to be detected at compilation time. So you want to give as much information to the compiler as possible to detect the errors. The same is going to be for getMaxStack, that is going to give you the maximum number of values in the stack. The difference between top and maxStack is that top gives you the number of current values that are in the stack. MaxStack will give you the total size of the stack, the maximum size of the stack of elements that you can use in the stack. Then prints the values in the stack as well as read only, and then you are going to have the destructor, right? The destructor that is going to be where we are going to execute. That is going to be called when the object is deleted, and it's going to execute methods. It's going to deallocate any memory that you have allocated here. Now, this curly bracket has to be after the tilde stack. Okay. So this tilde stack is the destructor is going to be called when the object is going to be deleted.